Okay, so I guess I ended up having to do 3 videos, but that's all right. Got to get all the information in, right? All right, so we should be on number 18 now. Okay, given the exponential model, which is just an equation, just fancy, of y equals 200 times 0.8 to the x, tell whether the model represents growth or decay, and then name the growth or decay factor, the initial amount, and the growth and decay, percent. All right, so first thing, we're going to look right in here in the parentheses because that is where we decide if it's growth or decay. Remember, if we multiply by 1, it doesn't change. If we multiply by something bigger than 1, it's going to get bigger, and if we multiply something smaller than 1, it's going to get smaller. This is 0.8, so I know right now that this is a decay. All right, so tell whether it's growth or decay. Well, this one is decay. All right, the growth or decay factor. Well, the factor is what we multiply by. That's what factors are, and that is 0.8. Okay, so the growth or decay factor is 0.8. All right, the initial amount, which is our P, is 200. So that means that the rate of decay, since this is 0.8, which is same as 80%, then that must mean that our decay rate is 20%. All right, because remember that we're always comparing this number to 1. All right, so if you think of money, you have 80 cents, that means you lost 20 cents. So your rate of decay would be 20%, or 20 cents. All right, on to the next one, compound interest. Compound interest is very similar to our growth and decay equation. The only thing that's different is that the whole idea with compound interest is that interest is figured out at different times of year. It could be figured out once a year, which would be yearly. It could be figured out weekly, which means that would happen 52 times a year. Quarterly would be 4 times a year. Monthly would be 12 times a year. Daily would be 365 times a year. So we basically use the same formula as growth and decay. The difference is that we have this value of n right here. And n is the number of times interest will be calculated. All right? So what we need to remember is that if it's 12 times a year, then we need to divide the interest rate by 12. And then remember that we have to change our years into months. If it's weekly, then we have to divide by 52, and then we have to remember to change our time into weeks. So it's just the same number is used in both places. We just have to remember to fill that in. All right, so number 19, you invest $2,250 in a bank account for 15 years. If the bank offers 3% interest, how much money will you have if the bank compounds monthly? All right, so things that we know is that the P is $2,250. We know that our rate is 3%, and we know that the time is 15 years. It's asking for compounded monthly. That means that the N is 12, because monthly occurs 12 times a year. So remember, it's the number of times each year. So monthly would be 12. So now we're just going to use our formula here. So f of x is $2,250. 1 plus, because we're making money, 3% would be 0.03 over 12. And then 15 years, 12 months in a year. So that's going to be our exponent. All right, so when we go to the calculator, some of this you might want to do, you can do this whole thing actually at once, but it requires a lot of sets of parentheses. So here we go. Let's try and see if we can get this all entered in here. So we have 2,250 parentheses 1 plus 0.03 divided by 12. Then we're going to close the parentheses. We're going to use the exponent button, but in the exponent, we need to use parentheses and say 12 times 15. Close the parentheses and then hit equals. And at the end of 15 years, we would have $3,526.72. And since it's money, we will do 2 decimal places. So in 15 years, we will have that much money. All right, for the next one, you deposit $200 into a savings account that's earning 4.5% compounded monthly. So we have that information again. So how much will be in your account after 5 years? All right, so our principal amount is $200. That's what we started with. Our rate is 4.5%. We're compounding monthly, which means N is 12. And then the time is 5 years. So for our equation, we have 200, 1 plus. Now remember, we have to change this into a decimal. So it's going to be 0.45 over 12. And then our exponent is going to be 12 times 5. So in 5 years, there will be 60 months. All right, so after this, we're going to go over to our calculator, and I'm going to enter as much as I can. So 200, parentheses, 1 plus 0.045 divided by 12, parentheses. So I've entered all of that so far. Now I need my exponent key, and in my exponent, I can either type in 60, but if I don't, I have to use parentheses and say 12 times 5. And the calculator will calculate that. If you forget to do parentheses, it's going to do this whole part you typed in to the 12th power, and then it's going to multiply that answer by 5, and that's going to be very different. All right, so after 5 years, you will have, let's see, I got $250.36. All right, that's compound interest. Last thing, average rate of change. We do average rate of change whenever we have a curve, all right? Because average rate of change is basically slope. We figure out the average rate of change by using the slope formula, but it only works on curves, okay? So instead of saying it's a slope of a curve, we say it's the average rate of change of a curve. So what we're doing for the rate of change is y minus y over x minus x. So what that means is that you have to have 2 ordered pairs, because that's the only way that you can figure out slope. All right, 21. Find the rate of change of this equation over the interval 2, 6. Those are the 2 x's. Remember, whenever we do intervals, we always do smallest to largest. So what that's telling you is that you need to use the 2 ordered pairs, 2 something and 6 something. So these are the x values. Now, the question is, where are we going to figure out the y values? Well, we were given an equation. So we're going to plug in 2, work it out. That will be one of our points. Then we'll fill in 6, work it out, and that will be our other point. All right, so first let's do the 2. So 2 squared is 4, 3 times 4 is 12, 12 minus 10 is 2. All right, now I'm going to do this point. Fill in 6. 6 squared is 36. 3 times 36 is 108. Minus 10 is 98. So now we will find the rate of change. So y minus y over x minus x. That's going to be 96 over 4. And we can, oops, sorry, forgot I was off screen. We can reduce that to be 24. So the average rate of change is 24 over 1, or you could just say 24. All right, last example for Unit 4. Here we go. So this one, again, we're finding that rate of change over the interval 0, 3. Well, this time it's on a graph. So these are the 2 x's. Well, the points are marked on here. So this point is 0, 4. and this point is 3, negative 3. So those are how we're going to get our 2 points this time. So basically, we can't really describe this any other way than basically finding the slope between those 2 points. So the rate of change is going to be y minus y, so 4 minus negative 3 over x minus x. So this is going to be 7 over negative 3. So we would say that our rate of change, is negative 7/3, which tells us that it's decreasing. Or if you wanted to, we could make this into a mixed number. So 3 goes into 7 twice with 1 left over. All right, that takes care of Unit 4. So now that you're done, you can work on your practice.